Picture this. You are working on a dream project and you are building an amazing API. And the cool thing is that your users are loving it until the day that it pumps. Everything goes wrong because of a massive spike of requests. And now everyone is stressed out, especially your team, but your clients are not happy with it. And you don't know why the hell this is happening. And this is where rate limiting can help you. And by the way, for some reason, big companies like these ones use it. This video is not sponsored by them. So, rate limiting is like setting a capacity limit or a speed limit for your API. You will control the amount of requests that a client or a user can make to your API during a given time frame. Think about it as car parking gates. A car park has a limited number of spaces. So when it reaches full capacity, the gates will be closed and will not let anyone comes in until the moment that someone leaves the park and now we have a new spot available that someone can take. This ensures a proper experience for those that come into the park and for those that are already in the park. Can you imagine that you had to go through the gates to find out that there's no spot available? By the end, you will need to pay as well. The same thing happens in an API. If you have rate limiting in place, you can stop requests from coming in and consume resources of the system. This will increase stability and provide a better performance for everyone. But it doesn't need to be another rule like this one. For example, in a car park, you can have a different type of access for those that are VIP clients, for those that have reserved spots. So for those ones, even if the park is full, they might be able to come in because for those, you already have a reserved spot, no matter if the rest of the spaces are already taken. The same thing can happen in an API. If you have a priority request, you can let it come in. You can even bring this concept of premium users and the other users into your API. So while a premium user can always come into the system, some user that is using free resources, is not paying for anything, you can block it on the way in. And in the same way that when you are driving your car, you are going to the car park, you will see the gates closed and the message saying the park is full. On an API, you will get the response saying 429, too many requests. The small difference in this analogy is that while in a car park, things are quite predictable because you know the number of spaces that you have. In an API, things can't go that way because different types of requests will consume different types of resources. They might take more CPU, they might take more memory. So you need to take different decisions. So usually what will happen is that rate limiting will be based on a specific time frame. Rate limiting will be the gates of your API based on the requests on the way in. You will have a counter and will decide how many requests should I accept during this specific time frame. If a new request comes in and it exceeds the predefined threshold for that counter, you will block that request. But why do we need this? First, it might be for protection. Someone can be malicious and try to do a DDoS attack to your API, denial of service. Another reason is to conserve your infrastructure. You want to avoid resource starvation, for example. As an example, if your API becomes so popular and someone comes and brings a new client on top of it, it might be so demanding and perform so many requests that things will go wrong for everyone. And this leads to the noisy neighbor problem, where one specific client or user can do so many requests, use so much that API that will lead to resource starvation and impact the performance of other users. It's also great for operation reasons. Example, cost reduction. If your product is using an AI model, you don't want to go to bankruptcy. So having limits in place will ensure that. And finally, there's business reasons. For example, if you are in a freemium model, your free users might only be able to use your API for 5 requests per day. And even for your paid users, you can have limits. For example, you can set limits like you can't create more than 2 accounts per day. You can't post more than once per minute. You can't send more than 1,000 messages per month. So you can use rate limiting not only to conserve your infrastructure, the costs and all of that, but also to bring to the reality many of the small rules that will be part of your business model. But maybe you don't have these business reasons to have rate limiting in place. You don't have those limits of number of requests that type of user can do. And you're just concerned about the impacts on your infrastructure. So you might ask, why don't I just bring auto-scaling in place? One of the reasons is that auto-scaling takes time. So at the moment that the scale was finished, once you already have those instances running, the request might have failed already because you had a spike of requests in a given moment. But how rate limiting works? So the idea is quite simple. Imagine the following. You have a new request and you will check for the IP address where that request comes from, how many requests have they done on that time frame. If the amount of requests on that counter is lower than the threshold that you define it, you accept the request. It goes in, it's processed. However, if it's above that threshold, we'll reject the request with the 429. And we want to do this as soon as possible because we need to reduce the latency on your system, and also we want to reduce the resource consumption, so we need to do it as soon as possible. This is a simplistic description on how rate limiting works, because the reality is that you have different types of algorithms that you can apply to rate limiting. You have things like the leaking bucket, the token bucket, the sliding window, the fixed window. You have many different approaches, just to name some of the most popular ones. But if you want to know the differences between those, please subscribe because there's a video coming soon. If rate limiting needs to happen as soon as possible, where should we place it? So let's start from the soonest place that it could be, that is the client. If we add it to the client, the problem is that it would be unreliable, and we couldn't make sure that all the clients of our API would apply it. But also, I couldn't enforce things like the same user using two different clients. How do I ensure that that user can perform more than the number of requests that it has assigned to it? So we move to the other side, to the server. But inside of the server, there's different ways to approach it. It might be an implementation inside of your API. You can bring something into your API that will apply rate limiting. So it might be part of your ASP.NET application, or it might be part of your Node.js application, but it's code inside of that API, something that will act when a new request comes in. The problem with this approach is, once again, scalability. Once you start going into things like a scalable system, it's a good idea to do it in a different place sooner. It can be something like an API gateway. And the good news is that if you are deploying your application to the cloud, most API gateways that you can find will have rate limiting in place already. You just need to configure it. Keep in mind that when you have something like an API gateway and you want to apply rate limiting, there's some tricky things that can happen. Since you have a distributed system, you need to make sure that you apply those rules consistently across the different nodes of your applications. So if you have scaled out your API gateway, you still need to make sure that for that user that has a free account, it can perform more than 5 requests. Not that that would be an hard limit. Eventually, you can accept that it goes to the 6 or to the 7, but you don't want that user to go to the 10, for example. So you need ways to fight that. And one way is by using something like sticky sessions. You make sure that all the requests for that user go to the same place to enforce the rate limiting rules. But this is not fault tolerant, so if that node goes down, you have a problem. How do we fight that? We can bring something like a centralized data store, something that is not the traditional database that can make things go extremely slower, but something like Redis, for example, can work perfectly to ensure that we have those counters quickly accessible and easy to increment. But let me tell you that rate limiting not only solves problems, but also brings challenges. Let's start with the challenges for the client. Now that your API has rate limiting in place, your client needs to bring fault tolerance in place as well. Why? Because the request might fail if it goes across the limit that you have defined. So that means that it needs retry policies in place. It can use something like an exponential backoff to make sure that it doesn't request the same thing over and over again with a given frequency. And also, it can bring something like a jitter to make sure that there's some randomness in the request that it's making. So this will bring complexity to the client. But in the server, there's other types of concerns that you need to have. The first one is that now you need to decide how to find the identity of that request. It might be something as simple as the IP address, it might be the client name, or an API key, a typical approach that you find in most public APIs. If you are following the approach of having the rate limiting inside of your API, it's a great idea to use a library for that. Something out of the box that you don't need to implement yourself. There's a lot of things about rate limiting that are already done. There's no need to reinvent the wheel. But the biggest challenge is to find the definitions, the parameters, the configurations that will define the breaking point of your application. So you need to find the breaking point, the moment where your API can get into resource exhaustion. So you don't want that limit to be too low, but also you don't want it to be at the moment that things are already failing. There's a sweet spot, and that comes with a lot of work in terms of load testing and trial and error and adjusting and observing and monitoring, and keep an eye on the system to understand how to adjust those parameters. And that can be extremely hard, but there's an alternative approach for that is more adaptive, an approach that can lead with the specificities of the infrastructure that is now running. And that is one approach that is used by Netflix, and you can find it right here, where I show you how to implement that using .NET.